So here in chapter 5, what we're going to do is tackle methods and functional programming. So just as a comparison, really everything you have done through chapter 4 is essentially a one-of operation, right? So all of the code that you put together is really meant to be used completely within the scope, the use case that you are looking at for that one particular assignment. There's no real extensibility there. We can't take a lot of what you did in your work from chapters 1 through 4 and apply that to something bigger or apply that to something even just slightly different, because everything is essentially hard coded. It is concrete sequential. It goes from top to bottom, from left to right in that order exclusively, right? There's not a lot of reusability there. And really one of the big benefits we look to all of the programming languages is we look to a programming language to be able to do things very, very quickly for us. And we look for those programs to be able to change and grow as we need. And the way we do that is with methods. Now, a method is a block of code that has I'm going to call it a hyper-specific task. Now, what does that mean? I like to say that method-based programming looks a lot like a Lego set. Each one of those individual Legos doesn't accomplish a whole bunch on its own, right? But it's stacking together those little individual pieces of Legos that sooner or later actually gets to build something. And each one of those methods is like one of those little individual Lego blocks. Now, in and of itself, you might look at, the barrel Lego block, the little circular things, and you might go, you can't do nothing with that. The only thing that one Lego block is good for is being on the floor over here and angering somebody when they step on it. That is true. But when we start layering a whole bunch of those barrels together and we start adding other different Lego pieces, all of a sudden you've got, a castle or a dragon or the Empire State Building or whatever it is that we are putting together with the Lego set. So we use these methods to divide up our program. We assign one very small, very basic task to a method, and we say, you do this one thing, but we can call on you again and again and again and again to build something much, much bigger. So we are going to see example after example after example of this through the text here. You are going to see examples of this with the code samples after we go through all of this. But really, this is functional programming. These individual methods are functions, we call them. And a function does exactly that. It has some kind of, I hate to use the word here, but it's a function. It does one very specific thing. So this is on page 270, if I haven't mentioned that already. And we will scroll down just a little bit here. But you have been using main as the function. So the method main is where you've been putting all of your code to date. Now we're going to start to change that. We're going to use main rather, as what is known as the driver. It simply calls out to other pieces of code so that they can do their job, so that they can either display the result of their job or return values to main, so that main can use that to assign to a variable. You'll see all of this stuff. So that main can call to another function, so that main has our decision structures, potentially like if, else, or switch statements. It would have our looping structures in there. And then each little job that we would have hard-coded into main, we can throw out into a function someplace. Now, what I want to assure you is, if you've been thinking about this the whole while that I've been talking and you've thought, that's a boatload of extra code, you are correct. For things that we built in chapters 2, 3, and 4, that's a boatload of extra code. But what I can tell you the payback is that code that you build here in chapter 5, you can reuse in chapter 6. You can reuse in chapter 7. The code that you build in 7, you can reuse in 10 and 11. And the real benefit here is build it once, use it a bunch of different times. And that's the payout for modular programming. Each one of these modules that you build has the potential to be copied and pasted someplace else, or later on has the potential to be built as its own class, so that you can simply take that code, snap it in someplace else, and boom, we get new functionality out of it. So I just want to highlight here, there are two main differences between the kinds of methods that you will build. One of them is a void method. Now, a void method, now this is page 271. We've really made it a very long way from there, from the very start of the chapter, right? Here on 271, it is figure 5-2. A void method simply does something. It does not return anything. And you'll notice that main is a void method because it doesn't return anything. Once we're done with main, the program is done, right? The same kind of general structure works here with a void method. It's that once the job is done, it simply returns what is called flow of control. Whatever the line immediately following the call, and we'll get here, the call to the function was, the void function simply returns control back there, and whatever's next happens. So there's no permanence here to what happens inside of a void function. So actually a message, just like you see here on 271, is the perfect idea for a void function. It simply displays something. Great, there you have it. So you will use void functions plenty. They simply do not make a return. While we're here, we can kind of highlight the different parts of a method header. So a method header is going to be what lets Java know, hey, this is the user, this is rather the developer, defining what this method's function is going to be. So it is broken up into, it is 4 distinct parts. The first one is the method modifier. For right now, public is what you are going to use, and for right now, public static is what you are going to use. What I will say is, rather than make a huge speech on this now, I want to save this for the future chapter where it's actually supported. So for right now, just public static is really all you need to know about the method modifier, the very first thing that comes through when you are defining a method. The next is the return type. This lets Java know that either all of the work is going to be done here inside of the method, or you are going to take the result of a method and pass it along to someplace else. That's what the return is. We are going to see that, as a matter of fact, next, right after the 5.1 here. So void in this example is what you need. A method name, so we have to name it something. Display message, that's the one we see here on 271. Otherwise, it could be things like calculate tax. It could be things like get first name, get last name, things like that. The idea here of naming a method is you want as clear, frankly, a picture as possible for what it is that this method is going to do without getting overly complex. So display message might be good enough, but display welcome message, display exit message, display, entry message, things like that are probably a little bit better. But here in the scope of, 3 lines of code, it's probably not that big a deal. And finally is the parentheses. What the parentheses indicate to Java is, did this method receive any parameters, which we will get to, or did it not receive parameters? So, excuse me, the empty parentheses there mean you work with what you got. If there's something inside of the parentheses, it means that we have taken the result either from main or from another method, and we get to use that in there. We will see examples of parameters in the parentheses there as we go through. So that's, I love when that does that. The parts of a method. Now, calling a method is 273, essentially from within main or from within another method to make what is called a function call or a method call, or really just to make a call, would be to use the name of the method. So here it's display message, and then the parentheses. If there's anything inside of the parentheses, that means we are passing a parameter over there, but here we are not. We will see what that looks like as we progress. So in the code listing 5.1, I'm going to let you take a look here because we have a different example later on for defining a method and for calling a method. But essentially here in 5.1, you'll see it's line number 10 is making a call to display message. And down here on lines 18 through 22, actually 21, that is the method called display message. So you can see this here. You can see the sample output here. There's actually a couple of different ones there for you to see before we get to 5.2. And if it feels muddy just yet, that's because it gets better in 5.2, 3, and 4. So methods are just small blocks of code that do something, preferably that do something very, very specific. Display message, calculate tax, get first name, get last name. And in the short run, they'll increase the amount of lines of code that you have. That much is true. However, in the long run, what they enable you to do is reuse those blocks of code again and again and again across multiple programs even, so that they do a job, and it's a job that can be repeated, and that helps you reduce your overall workload in the long run. So you will appreciate this idea of using methods to do work sooner or later.